Hello and welcome back to Oasys Top Tips. Did you know that Oasys D3PLOT allows you to define user data which can be contoured on your model? D3PLOT comes with a built-in user data tool which allows you to contour your own values on a model. Here I have a tube which is essentially crushing into a wall here if I play the animation. And let's say I wanted to contour the displacements. So let's go displacements and then resultant displacements. If I press F here to give a shaded contour plot and animate it, we can see that the contour is dominated by the global Z displacement here. Whereas actually I might be interested to see how much it deviates from its initial position on plan, so in the XY direction. To do this, I can make my own user data. So clicking on user data and then clicking on new, I need to select what kind of data I'm going to write out. Because I want to write out contour data for the displacements, I'm just going to write that out to the nodes. So it'll be a node and then a scalar. That just means it's a single value. I also have the option of node vectors. So that would allow you to plot a vector arrow or solid and shell scalar, solid shell tensors, which is 6 values, and then beam scalars, vectors, and then others, scalar, vector, and tensors. So these are the 9 types that are supported, and I'm just going to start with the node scalar one. So I first give it a name here, so that's easy to tell what my component is. So I'm just going to call it XY resultant displacement. And then I've got options here. I can either read it from file, a simple formula, or a JavaScript file. To start with, I'm just going to show you the simple formula option. And if I'm not sure what is supported, I can click on the explain this here, and if I expand this out and go to the next page, we can see all of the different component names that are supported. And at the top here, we've also got some mathematical operations that are supported too. So we've got, for example, square root, which we're going to use in a second. There's also the power operator here, which is actually 2 stars. So just take a note of that if you've used a hat symbol, maybe in Excel or in different languages. For example, in JavaScript, use the math power method. Okay, so I just want to get the X and the Y displacement and the resultant of that. So to start with, I'm just going to get the dx component and I'm going to square that. And then I'll add the dy component and I'll square that. And then I just need to take the square root of that. So put brackets around and then go sqrt. And now I can create my component. I also have the option of saving a component, and that means that it will be stored for use in future models. So that's something I might want to do, and I can reload saved later on. But for now, I'm just going to create that component. And then if I go back to data, and this time go to user defined, I can see I've got my nodal scalar displacement defined already. Here's some values I've saved previously. So I'll click on that, and then now I'll contour, and you can see now we've got the resultant XY displacement, and if I give a side-on view, you can see how it's actually not dominated anymore by the global Z component. So that's user data for the simple formula. Next, I'm just going to show you how you can use the read from file option. So the read from file option might be useful if you've got some data already available. Maybe you've extracted XY data from the model or generated some data elsewhere, and you can format that data in such a way that it can be read in. So if I want to find out more, I could go to explain this and it can show me some information about the type of data it's expecting. Or if I go to the manual, I can see the data we're expecting here. So we want the component, so either a node or solid, beam, shell, T-shell, and then the type of data. So here we're just going to have scalar values. That's a single value per node, or in our case, we're going to be using a shell scalar. Then we can also define a default value and then the ID of the node or shell and the value. And because it's a scalar, we just have one value following it. It's also worth noting that this can be space separated, comma separated, or tab separated. So it should be able to accommodate various different file formats, and lines which are blank or starting with a hash, percentage, or dollar symbol are also ignored. So you can comment out various lines if you don't need them from another file format. Okay, so what I've done in order to generate the user data for the files I'm about to read in is I selected just a subset of the shells and then wrote out the XY data for those. And then I have reformatted that data so that the values for those shells are in separate files, and each file has a number before the file extension which relates to the state. One of the files might look like it's got, first of all, the shell scalar at the top, and then a default value for any of the shell IDs that aren't defined. So you can see that these IDs don't all increment in 1, there are some missing out, and so for those the value will be -1. Then everything else has its value defined on the right hand side, and this is just for a specific state. So in this case this will be state 1_1, and then we can see we've got all the other states 1 through to state 111. Okay, so first I'm going to change this to be shell scalar because that's what we're reading in. Next I'm going to open up the file, element data 1 here, and then I'm going to give it a name. So this one I'm going to call top tip plot. You'll see why in a second. Then I'll create that, and now I need to come back and change to a different user-defined component. So there we have top tip plot, and I didn't find anything for the 0 state, but if we go to the first state, we can see we have our top tip there. We turn off averaging, should make it nice and clear. And now we can see we only have the data plotted for those shells of top tip, and every other shell is this dark blue color, which is a -1. So that's something, a little bit of a toy example, but kind of fun and a bit nifty. If that's something you're after, you can contour and color your models by using these external files. Now briefly I'm just going to explain we also have other options here. So we have the JavaScript file, which is similar to the simple formula, except for with JavaScript file you also have the option of doing some conditional logic. One watch it with that though is that when you are writing a JavaScript file, all of the components are actually functions, so you need to put the brackets at the end of them, and the value returned from that script is the value that will be given for the specific shell or element or node that you are plotting data for. And because of that, the script then is run for every single entity that you are plotting. So it can be quite sluggish if you have quite a involved script. So that's just something to be careful of. And if you actually want a bit more control and you don't want to have to rerun the data all the time, but you'll run it once and then you can use that data going forwards, you might be better off by creating a binary data component. Now, a binary data component will appear just like any other data in here. However, the difference is that that will be made with an external JavaScript, and it will save a file in the location of your analyses. So when you open up the analyses again, you'll have that data already stored, and you've got a bit more control over how that data is generated with a full JavaScript file. So if you want to learn how to use the user binary components, or also known as UBIN components, then I highly recommend you taking the JavaScript courses that we offer. So you can look out for them on our website, and you'll learn lots of other things along the way. But I hope you found this top tip helpful, and I look forward to seeing you in the next Oasys Top Tips.